Well, good morning. Thank you for joining today's workshop on Able, which is a new data collection accelerator application offered by SmartSights. I am your presenter today, John Oskin, Senior Vice President with SmartSights, and happy to be talking to everyone about this application. So, SmartSights recently acquired a company called Sage Clarity, and with Sage Clarity, three new product offerings have been added to the SmartSights suite, and it falls along the lines of connected intelligence, connected machines, and a connected enterprise. So Peer is an application that works hand in hand with Win911 for alerts and notification follow-up. It's really an issue resolution plugin for Win911. OneView is a data collection, or OneView is a reporting accelerator, and what it is particularly good at is doing what-if analysis on manufacturing KPIs. And then today's discussion is really around Able, which is a data collection accelerator that can be used to support MES, OE applications with sophisticated data collection and data validation tools. A little bit about the customer base around some of these technologies. They fall in different industry sectors and have unique value propositions in each one of them. So, what is Able? Able models machine centers, but it couples it up with line flow to determine root cause analysis. And with that, it simplifies both the data acquisition and the control architectures associated with data collection. When the Able technology is implemented, it can improve data fidelity by up to 5 times and reduce integration costs by up to 70%. Able is unique in that it can actually feed data into both level 3, 4, and 5 in the control hierarchy here. So Able can feed SCADA applications, it can feed MES, and it certainly can feed directly into ERP applications. It's an agnostic platform. It works with a variety of MES and OE solutions. It is a low code, no code kind of environment, and really helps accelerate the time to value associated with data collection. So for MES deployments, Able can supercharge those deployments with what's called intelligent root cause analysis. What we're doing is we're taking machine state and fault data, and we're coupling up with line flow information. That's an important concept because it's not simply a matter of just collecting data from machines. For a connected production line in high volume industries such as food and beverage and consumer packaged goods, what happens is when a production line goes down, that downtime will propagate through the line. And so line flow is an important concept for kind of knowing this intelligent root cause analysis concept. Able can also bring in conveyance and count information into the configuration. These are cloud-based applications, so it enables enterprise level configuration. And you're going to see that there's some live graphics and diagnostics associated with the toolkit. So some of the benefits of Able really are around this time to value components, taking and reducing the time to value associated with data collection projects and increasing the data fidelity. And it's optimized from the edge. So the Able logic engine starts by taking raw PLC data, running it through a signal processing engine into two types of logic engines. We have a machine logic engine and a line logic engine. So machine logic engine is good for managing job state information, and then line logic is where we're looking at order routing, line level root cause analysis, that type of information. Able has some pretty sophisticated tools. So if you're an integrator and you're implementing MES or OE type solutions, Able has multiple tools at your disposal. First is a diagnostic tool for operators to actually evaluate configurations that Able is developing. There's also a diagnostic tool around a digital twin concept. And what we're able to do here is take historical data, replay it in a context around understanding distinct events that are occurring. So think about, if a machine went down and you're trying to evaluate whether the logic that was set up to evaluate that um, is really been coded correctly. This digital twin replay concept allows you to reevaluate that, and we'll show you that in the demo. Able has a fault learning concept, which is very unique. What fault learning does is it expedites configuration. So a typical machine can throw up to 500 faults. Of those, probably only 50 of those are repetitive faults. Although those are the ones that get configured in Able. So rather than embarking on a data collection project to try to codify all 500 of those faults, we focus on the repetitive ones. So the 50 that are reoccurring, and then in time, when fault learning stays in place, 6 months, 9 months down the road, what was a one-off fault may become a repetitive fault. And so then the systems integrator or the client can actually configure it at that time. That reduces significantly the time for both configuration and for data validation. Able also has some unique functionality for processing signals associated with speed loss. Speed loss in an OE project is a kind of a nebulous concept. Most applications think of speed loss as just the performance part of the OE calculation. So if my OE is 70%, maybe performance is 90% might be the index for that. But you can't break it down any further. What Ables allows you to do is break down that performance component or the performance loss. So if performance is 90%, the loss is 10%. So it's really breaking down that 10% further. And we can break it down into whether an operator has reduced the line speed, or whether the line control system has excessive ramp up or ramp down times built in there. Able can create a record structure to evaluate all that and help you understand the breakdown of that 10% loss component. And with that, let's go ahead and take a look at Able in action. So I'm going to start with configuration. So this is the configuration environment. It's a bit of a canvas here where I've got a group of assets, and it's as simple as just literally dragging assets onto the screen. And then the important thing is building out a line flow. So if this press operation feeds into this next press operation, Able will ask me whether I want to add root cause analysis to that. So I'm going to go ahead and say yes. Okay. I'll do the same thing on this next operation here. And then maybe after those press operations, it kind of comes back together into some other kind of operation. So again, I'm building out this logic here to show that. So what that does for you is I'm not just simply analyzing the individual machines, but I've made an association. I know that this press 2 comes after press 1, as does press 3. I also know that press 2 and 3 then come back together to feed this molding operation. This is an important concept when it comes to root cause. If I click on these assets now, this is where the configuration components come in. Again, we're doing this outside of the PLC. There's no ladder logic in this. So you get information about what PLC are we talking to, what type of an asset is it. In Able, we have 4 different asset types. We have a cell asset, which is really a machine asset. We have a line asset, which is the overall line. We have secondary assets, which are usually secondary operations, feeding operations, if you will, into a cell asset. And then we have virtual assets. And a virtual asset is where we can create an asset group. So if I have a bank of labelers, I might want to look at each labeler individually. I also might want to look at the labelers collectively, and I can do that with a virtual asset that I create there. We have items. Items are where we are providing information around run bit information, reason code data, status bits coming out of the PLC. And then conditions. We use a 4-state logic engine. So machines are either running, they're down, they're starved, or they're blocked. You can have multiple blockage scenarios, you can have multiple starvation scenarios, and typically you will have many fault scenarios. So with that, we are building out the construct for data collection. Once all this gets configured, it gets deployed. And when it's deployed, this is what it looks like. So we've got a little bit of a simulation running here. And with this, first of all, I can see what's running and what's down. So you can see that as a machine goes down, it's showing up in red. So from a data validation standpoint, I immediately have a good tool for understanding when machines go down. And then if you are engaging operators in that data validation process, we have a data validation view here where an operator gets a combination of some metrics and some raw data to look at. So on the right-hand side is the raw data. So Able is creating these uptime and downtime records. So you see how we're toggling between running and down, running and down. And when I am down, Able is figuring out, why is it down? So low fill, waiting on a forklift, part jam, so on and so forth. And then on the left is some basic information to help understand have we organized the data properly, for the MES or the OE application. So we've got a view here of uptime and downtime associated reasons. I have a downtime kind of only view, and then I've got some KPIs. So I've got machine availability, mean time between failure, and mean time to repair. These are typically important metrics kind of going into the MES system. So that's a bit of an operator view. Other things that Able has available for yourself is we can have multiple views. If I've got a large factory, this can be built out as large as it needs to be based on the size of the factory. I can also create multiple views. So this might be an overall factory view, but then let's just say that I am trying to validate just my assembly area here. So I have an assembly area view, which has this work cell operation and this production line. If I go to the next data validation screen, we create what are called these DNA views. And with the DNA view, what we are doing now is we have synchronized the data for this production line and all its unit operations here. So I've got op 10, op 20, op 30, op 40, and then the overall line. And what Able is able to discern for you as you kind of look at the uptime and the downtime that's occurring is we can screen out unimportant activity. So if I click on this root events button, what it's going to do is it's going to gray out everything that doesn't have root cause association. So the things that pop with color are what remain. So if I click on one of these now, you can see how I've isolated a sequence. You can see visually what happened here. As I hover over the line event, you can see it's already telling me that line 1 went down due to op 40. Well, here's what really happened. You can see that op 40 went down. You can see how it cascaded, and then it took op 30 down. It took op 20 down, took op 10 down. This is the point when the entire line went down. So Able was able to kind of discern that Op 40 really started it. So these 5 events are really one event. It's the same event, all tied to Op 40. Everything else is secondary. The other thing that Able can do is it can actually look at your historical data to validate. So here we're looking at real-time views, but if I were to select a different time frame, so let's just say I'm going to look at yesterday, and I wanted to look at a time period yesterday, and maybe it was, maybe it's yesterday afternoon, maybe it was around, 4 o'clock in the afternoon. So I'm going to apply that filter. Um, so visually, it's going to look the same. But now what I'm going to do is I'm going to look at the replay validation functionality. So if I click on replay now, what it's doing here is it is marrying up the line flow with this DNA view. And I can kind of, manipulate this and move it up and down into view as I see fit. But now what I can do is I'm going to replay what happened yesterday from 3:45 to 4:45. I click on the play button. It's going to start sequencing through the information. I can fast forward. I can pause, or I can drag it to a point of time that's of interest. So I'm just going to drag it over here to a sequence where something interesting happened here. So here you can see around 4 o'clock, Op 40 went down. There you can see it took down Op 30. Go a little further, took down Op 20. Boom. When Op 10 went down, you can see here now that it actually took the overall line down. So now I replayed this sequence here of progression that started with Op 40 going down that actually took the whole overall line down. So if you're in the middle of a data collection project and you're trying to validate the able logic to assess, do we get it right? You now have a mechanism for doing that. And then if it's not right, what you can do is you click on the share button. And if I click on the share button, what I can do is I can just, email that link. And what it's going to do is if I send it to someone that has an able login ID, if they were to click on this link, it's going to take them straight to the view where we were at, so they can actually replay the sequence. So very powerful for sharing and collaborating with other engineers on that point. Able also has data validation tools for KPIs associated with the data collection. So if I were to go back to that layout view, and we're going to go back to the overall factory view, which has, all my machine assets on there. I can take this view and turn it into a heat map. Okay. So if I were to go and look at an availability heat map, I get a similar graphical view, but I'm actually conveying something different here. So what I'm doing is I'm taking the availability metric that's been calculated and I'm putting it into a red, yellow, green heat map. So you can see here that all these assets are in green. This Molder 6 here, or Molder 8 rather, is in kind of a lime green color. It has thresholds that say that anything above 96 is in green, anything below 35 is in red. So it's kind of in the middle here at 84. That's why it's in this lime green color. So, this one has a lower availability index for evaluation. If I were to take a look at mean time between failure, I can now look at my MTBF numbers for these individual assets. You can see that a bunch of them are in red based on their thresholds that have been set. And that might be something that might be of interest to a maintenance manager that's trying to review this type of information. And then mean time to repair is when a machine goes down, how long does it take to get the machine back up and running? And so now everything's back in green. So at least, if I'm a maintenance manager looking at this kind of data, at least I know that that the machines are getting operational again in a timely manner. And then finally, rate data. So similarly here, you can see this Molder 5 here is in orange. It's got thresholds between 55 and 88. That's why it's kind of in that orangish color, close to red. Um, so this can be used both for data validation, but also can be used as an interface on the shop floor to supplement the HMI that may already be out there, to provide some feedback for operators and for plant staff that are focusing on making sure that machines are running at the right rate. So if they're not, machines are going to show up in, red or yellow. If they are operating at rate, then everything's going to be, green and happy. So that's a little bit on the Able technology. There are a number of tools at your disposal once the configuration has been established. And with these tools now, I can have tools for data validation, supporting data validation through these DNA views. I have an operator view that can assist with evaluating the events that have been constructed and how it marries up with the KPIs that are being calculated from the data. And then I have tools for maintenance staff to be able to kind of look at this information in real time to understand, if machines are performing effectively. A little bit on the Able architecture. So Able is a cloud architecture environment. Um, it can be installed on premise, um, but what Able is doing is it is talking directly to the PLCs through an Able Edge service, and then think of it as a middleware application that then is then feeding those records that I showed you into the other system, whether it's a SCADA application, an MES application, or even an OE application. And then the tools that I was showing you on screen are cloud. So configuration done in the cloud. The visualization that I was showing you, again, done in the cloud. And all of that is available for viewing on a desktop, on a smartphone, on a shop floor PC. Having said that, Able can also be installed on premise. And when it's installed on premise, then these components really become private cloud kind of applications on a local server. So we can accommodate both. And then finally, I'll wrap up with a case study. So G&J Pepsi is a large Pepsi bottler, and G&J started with manual data collection. And what they found was that with their manual data collection, they thought they were getting about 75 downtime events on one of their, bottling lines over the course of a week. Well, they realized that when they put in real-time data collection, they were getting 10 times that, significantly greater downtime than they realized. G&J Pepsi deployed Able as part of its MES project. And with that, we deployed 4 sites in less than 4 months, averaging about 4 weeks per site. With that, giving them a 70% reduction in the engineering time from what was originally allocated for the project, and really great visibility into their minor stops that they had, poor visibility into prior to this type of advanced data collection. So with that, we'll take a few questions. So let's just see what kind of questions have come in here. We've got a question that came in on whether Able requires a lot of hardware. And so the reality is that Able is really a software application. It is communicating with the PLCs. There's no hardware involved. The Able Edge service can be installed on a local, if there's an MES server that's being installed, it can be installed on that server, or it can be installed on an edge device um, as a precursor to an MES or an OE type deployment. Another question came in. Does Able require MES? Um, Good question. So the answer is no. I mean, Able can be a pre-MES type system. So you can put Able data collection in as a precursor to MES or an OE project. Um, Develop the data collection, use the validation tools, use some of the visualization tools, and then in time, maybe then the next step would be to implement full MES or to implement a full OE type application. But at least you've got the data collection portion already started with it. Um, no other questions have come in. Um, you can see on screen here if there's more follow-up needed. Follow up with your SmartSights representative or just contact sales@smartsights.com and we'd be happy to follow up. So with that, we will let everybody get on with the rest of their morning and thanks for attending today's session.